Okay, we're going to take a look at elimination here. So elimination is another method for finding what's called a system of equations. So we have something here. This is two linear equations. So I'm going to do a rough sketch here. And one of them has a y-intercept of 2. Okay. And just so I remember how I find that, y is equal to mx plus b. M represents our slope, and b, that represents our y-intercept. So we have a y-intercept of 2, and it goes up 3 over 1 and down 3 over 1 the other way. It has some kind of slope. Looks something like that as a rough sketch. Our other line has a y-intercept of -1, and it goes down 4, 1, 2, 3, 4 over 1. And this one goes up 1, 2, 3, 4 over 1. So it does something like that. So cross is somewhere in this range, but I don't know the exact value. So I'm going to use algebra to find it out because my general sketch isn't very precise. So we did a method of substitution before. This time we're going to use elimination. Elimination, what we need to do is we need to line up all of our like terms. So first of all, let's take a look. We have a y in both equations, and I'm going to label the two equations. We'll call this equation 1 and this equation 2. And we have a y. We have a coefficient with the x variable in both equations. And then we have some constant term, which is our y-intercept in both equations. And it just so happens what we're going to do is we're going to stack them on top of each other. So I'm going to put equation 1 here. I'll write it out again. Y is equal to 3x plus 2. And equation 2 is equal to y equals -4x minus 1. It just so happens that all of our like terms are on top of each other. This works out great. The y's are on top of each other, the x variables are on top of each other, and the constants are. So that's really nice. In order for elimination to work, we have to get rid of some variable. I could technically get rid of the y here, or I could get rid of x. Okay, I'll tell you it's way simpler to get rid of y at the moment because they have the same coefficient. And I know there's no number there, that just means 1. What I'm going to do is I'm going to actually do the hard way, and then I'm going to show you the easy way. So maybe I don't recognize that I can get rid of y really easily. I'm going to get rid of the x. In order to do that, I need to make the coefficients the same. To make coefficients the same, I need to find a common multiple. 3 and 4 have a common multiple of 12. Really a fast way to do it is just multiply the two coefficients by each other. So if the coefficient is 3 in equation 1, I'm going to multiply every term in equation 2 by 3. And if the coefficient in equation 2 is -4, I'm going to multiply every term in equation 1 by -4. All that's going to do is going to give me equation 1 times -4. And what that will look like is that will be -4y is equal to -12 x and then -8. And it'll also give us equation 2, which we multiplied by 3. And that will look like this. 3y is equal to -12x minus 3. So now when we take a look at this, we still have everything stacked on top of each other, but I got a common coefficient here. And that common coefficient is important. What it allows me to do now is if I subtract the two equations, so I'm going to use subtraction sign, okay? This variable is going to have a coefficient of 0. -12 subtract -12 is the same as -12 plus 12, which gives us 0x, okay? And that's really important because essentially x disappears. But I also have to carry out that operation on the y's and the constants. So -8 subtract -3 is the same as -8 plus 3. That'll give me -5. And -4 subtract -3 will give me -7y. Now that x is technically gone. 0 times x is 0. We can just kind of drop it off. So we now have -7y equals -5. This is good. We have one variable, y. So we want to actually just get y all by itself. At this point, I think we're pretty proficient. We know that, hey, if I just divide both sides by -7, this side creates a 1, and we get y is equal to -5 divided -7, which is actually equal to 5 over 7. So that's going to be our y value. So in this case, we actually found the y value first, which is 5 over 7. That's some decimal. We could divide it with a calculator after. What I'm going to do, though, is I'm going to carry out that same operation over here, And I'm going to write the original equations, 1 and 2, y equals 3x plus 2, because if you remember I said it was already set up to get rid of the y's, and hopefully now we understand that concept. There's a 1 in front of both of those y's. So if I subtract the two equations, and we work this out, -1 subtract 1 gives us 0y. Oops. 3 minus -4 is the same as adding 4. That gives us 7x. And 2 minus 1 is 2 minus -1 is the same as 2 plus 1. Gives us 3. This y cancels out. You're left with nothing or 0. Remember, 0 is the representation of nothing. So 0 is equal to 7x plus 3. I'm going to move 3 to the other side. It will become -3 equals 7x. And similar to before, hopefully we're pretty proficient. We're trying to get the variable by itself. When we divide the two, we end up with x is equal to -3 over 7. Some fractional value. -3 over 7. Okay, we can double check that this is correct here. We'll punch in our two equations. Let's make a new blank document here. Our first equation read y was equal to 3x plus 2. Okay. And our other equation read y was equal to -4x minus 1. All right, there we go. In decimal form, this is what our values are. Let's double check and make sure. Do I have a scientific calculator up? No, I don't at the moment. Let's do Desmos. Well, I guess we'll do graphing. And then I'll just go into Matthew. Scientific. Here we go. So let's just double check. We'd originally said our x value was -3 divided by 7. That gives us -4.2. And that's what we got for our x value. And let's double check our y value. Our y value was 5 divided by 7, which is 0.71 ... 0.714. So that's it. We got it. We used elimination. We used elimination here to actually get through this process. And in some instances, some people might find this a much quicker way of solving than substitution tends to be.